Welcome. In this episode, we're gonna do some practice problem. Actually, one practice problem, our first practice problem. Okay? And here is the question. A cyclist goes uphill with an average speed of 20 kilometers per hour and then returns back downhill at 40 kilometers per hour. We need to calculate his average speed and average velocity for the round trip. Okay? So let's begin. The first step is to always make a drawing of the situation. Let's see if we can do that. So here is an uphill, okay, and there's a cyclist. So here's my cyclist, okay. Basically everything in physics is going to look like Bob, alright. So he goes uphill at an average speed of 20 kilometers per hour. Now I really don't know whether he's going uniformly or whether he's stopping in between and doing that. It doesn't matter because again finally the question is average speed, so I might as well just assume uniformity, and so I'm just going to assume he's moving this way at 20 kilometers per hour and then returns back downhill at 40 kilometers per hour. So we're going to make an assumption that he just goes zoop and then immediately returns back. So I'm going to draw the returning over here, and he returns back this way, 40 kilometers per hour. And we need to calculate his average and speed and average velocity. Let me do the velocity first because that's the easiest one. Can you see why it is the easiest one? Because it's given that it returns back. That means if this was his starting point, so if this is the starting location, well then Bob reaches back to this particular point. So what's his displacement? Think about it. Initial position and the final position are the same. Displacement is 0, therefore his average velocity is 0. So solution for the first problem, we have average velocity is 0. Why? Because initial point, I'll call it as IP, and final point are the same. Okay? Well, that's easy. Let's go to the next one. Calculate his average speed. How do we calculate the average speed? Well, I'm gonna first have an attempt, and I'm pretty sure this is what you would want to do. You would say, well, average speed, let's average these guys out. So you would probably say average speed for the whole trip would be average speed during the first part of the journey plus the average speed during the second part of the journey, and you divide it by 2. So you get 20 plus 40, you divide that by 2 and you get 60 by 2. That's 30 kilometers per hour, right? Yay. Well, this is wrong, okay? There is no formula which says average speed is average speed in the first part of the journey plus second divided by 2. This is horribly wrong. This is the wrong way to do the problem. Now, allow me to explain to you why this is wrong. If you're not interested in why this is wrong and you want to go to the right step, you can just go skip ahead. But I'm interested in telling you why this is wrong, so you get an understanding. Just don't take my word for it, but you understand why it is true. I'm gonna give you an example. An example which you may be familiar with. Imagine a classroom, okay? A class of 50. Okay, so there are 50 students in the class. They take a test and some people get, let's see, some people get 10. They score a 10 out of, say, 100, and some people score 90. That's what's given, all right? These are the scores, okay? So you get, this is the scores. You find that some people get 10 and some people get 90, but I don't tell you how many. So what's the average value? Would the average value be 10 plus 90 divided by 2 equal to 50? Do you think so? Is that the value? The answer is no. It's not the value, because to calculate the average value, you need to know how many students got 10 and how many students got 90. This only works provided equal number of students got 10 and 90. That means 25 students got 10 and 25 students got 90. If that is true, only then we can say the average is 50. Otherwise, we need to know. Let me give an example. Suppose I find out that 49 get 10 and only one dude gets a 90. He's gonna get beaten up, but that's not the point. The point is, what do you think will be the average value? I'm not going to do the calculation. I don't want to do that. You guys can do it yourself. But the average value would be very close to 10. Because most people got 10. One person got 90, yes. So you average it out, you get something a little bit more than 10 because of this guy, but it will be very close to 10. Alright? So it's important to know how many students got this particular number. And the same is the case over here. We know that in the first part of the journey he's going at 20 and the second part is going at 40, and since we're averaging with respect to time, we need to know in which case he spends more time. If you're doing it this way, you're making an assumption that Bob, or the cyclist, is going at 20 kilometers per hour and 40 kilometers per hour for the same time. If he had spent the same amount of time with these speeds, then yes, this would be true. Unfortunately, that's not the case here. What is given is that the distance is the same because he travels uphill and then comes back downhill. Now think about it. He's traveling uphill, he's climbing the hill slowly, but he's going back down very fast. That means he's spending more time with this speed compared to this speed. So do you think the average value is going to be 30? No. The average value is going to be less than 30. I can predict that much even without doing any calculation. It will be more towards this guy. It'll be more towards 20 kilometers per hour. So it'll be less than 30. Think about an extreme case. Imagine this fellow cycled for 10 years. Right. Alright. Anyways, he cycles for 10 years with 20 kilometers per hour, and then for the next 5 seconds he goes at 10,000 kilometers per hour. Imagine that. What's going to be the average speed? Well, that's going to be 20 kilometers per hour, because for 10 years he spent 20 kilometers per hour, and for 5 measly seconds, even if he's going at the speed of light, I don't think it matters much. Right? Okay, so whatever. Okay, I really don't know about the speed of light, whether that's going to matter, because the speed of light is huge. Anyways, you get the point. Alright, so the answer is going to be less than 30. So let's figure this out the right way. So this is wrong. Okay, so now we have the right solution. What is the right way to approach a problem? Well, you try and think of the formula that you know. Okay, there's only one formula for average speed, and that formula is the total distance divided by the time taken. That's the only formula we know to calculate average speed. What is the distance traveled? Well, we need to calculate the distance traveled for the round trip to go here and then come back. So what we'll do is we'll divide this into two parts, alright? So we'll take, let's say, uphill first. Look at this case. In the uphill, the distance traveled is d. Okay? The distance is d according to my drawing. And the speed, it's average speed, but that's okay. That's average speed. Alright, fine. The speed is 20. So what's the time taken uphill? I'm going to call it as t1. Let's see. Speed is distance by time, so time is distance by speed. So it is distance d divided by speed 20. And what happens downhill? Let's see. Downhill, well, the distance is the same. The average speed is 40. Therefore, the time he takes is d by 40. Can you see? Spends less time, d by 40. The denominator is bigger, so he spends less time over here. He spends more time over here. And so now we can plug these things in over here. So let's do the calculation. So the average speed for the round trip, this is for the round trip, is going to be the total distance for the round trip, that's d plus d, that's 2d, divided by the total time, that's t1 plus t2, that's d by 20 plus d by 40. Now all we have to do is simple algebra. So d cancels out. So I get 2 divided by 1 by 20 plus 1 by 40. Let's get rid of this guy. And we take the common denominator. That's 40, that's a 2, that's a 3. So you get 80 divided by 3. What's 80 divided by 3? I am too lazy to do the calculations. So I just go back to my calculator. 80 divided by 3, and my handy calculator says, you can trust my calculator, not my division, it's 26.7 kilometers per hour, and that's perfect And that's perfect because that's what we predicted. We predicted that. We predicted that it's going to be less than 30. Alright? So that's how you calculate problems on average velocities and average speeds.